Okay, so here's our next example that we're going to look at. So it's nice. They have a picture drawn for us, which is good. So let's read it. To measure the height of clouds, a spotlight is aimed vertically. Okay, so here's the spotlight. It's down here on the ground and it's shining vertically up. Okay, and I will actually draw a line that is vertically up and I'll do it in red. Okay, so it's shining up into the clouds. Two observers at points A and B. Okay, so here's one person looking, here's the other person looking. 364 feet apart in line with the spotlight. So it means that if I drew a line, first person A, spotlight, second person. So it's not ziggy-zaggy. So it's not like this, but the spotlight means that they are in a direct line of the spotlight. And we're also told in line with the spotlight, measure angles. Okay, and these are Greek letters as shown in the diagram. Okay, so we have 72.5 degrees and this person measures 47.8 degrees. The question is, how far from the ground is the bottom of the cloud level? Okay, so we're after how far is that from the ground? From the ground up to the bottom of the clouds. Now you can see the way this is drawn, we actually do have a right angle triangle here. We actually have two if we want to look at it that way. The only thing is, I don't know enough information about either one of those triangles. I have an angle for each one, but I don't have a side length. So I'm going to look at the large triangle first and see what we can do there. So the first thing we're going to do, so this is A, we'll call the angle where the clouds is C for clouds, and B obviously is person B. So the first thing we're going to do is we're going to look at this picture, and I'm just going to take away the straight line for a second. I'll put it back when we're looking at it again. So I'm looking at the large triangle ACB. Now, I have two angles there, but I don't have the third one. And do I need the third one? Well, yes, I do. And the reason I need the third one is I have a side, and directly across from it, I would need to know that angle. So how can we find angle C? Well, we can find it actually quite easily. And I'm going to get rid of that long line now that I've pointed it out to you. So let's go back to the question and we can actually figure out the sum of the interior angles of a triangle need to be 180 degrees. So that's the first thing that we're going to do. So angle C is going to equal 180 degrees minus our 72.5 and our 47.8. And when we do that, we end up with 59.7 degrees. Okay, so that is 59.7 degrees. And I'll just put an arrow so I'm not cluttering up our picture. Now, what do we need to find in order to solve the height? Well, as I pointed out to you before, we did have a right angle triangle, but we were missing a side. So we can either find side B or we could find side A. And it really doesn't matter which one you actually find in order to do that. For some reason, my brain is saying, I want to find side B. But as I said, it doesn't really matter which side you do find, A or B. So I'm deciding that I'm going to find B. So using the sine law, I know that B over sine of B equals A over sine of A and C over sine of C. No, I didn't put them in order, and that's fine. They don't have to be. Now, I'm interested in B, so B I want to find, and I know angle B is the 47.8. And I also know C, so I'm not interested in this one. I know C is 364, and its angle we found was 59.7. And just like all the other questions, we're going to cross multiply and then divide. So I'm going to go B sine of 59.7 equals 364 times the sine of 47.8. And then we're going to divide both sides by the sine of 59.7 in order to get B by itself. And when we do that, we take our calculator to calculate the right side, and we end up that B equals 312. Okay, so B equals 312. Now remember, I could find using the sine law side A, but that doesn't help me because I'm really interested in H, which is in the large triangle. So what I'm going to do now is I'm going to take and look at triangle AC, and I didn't label this here, so I think we'll call it D, just so that we're all on the same track, and I need something to write with. So we'll call that D. Now, sometimes what I do as well is I redraw the triangle because after a while it gets pretty messy and it's harder for my brain to see what's going on. So I'm going to draw one, and obviously I have to flip it because it doesn't look the same. Okay, so obviously this doesn't look quite the same as the triangle I have here, but it's close enough for what we need. And so I have my right angle at the bottom. This is the H I need to find. This is angle D, angle A, angle C. I know this is 312. So I'm just transferring the information that I have onto my small triangle. Now, because I've redrawn my triangle and I'm going to do the work right here, I don't have to say what triangle I'm looking at, or I could. Either way is fine. Okay, so now I have it here, and this is a right angle triangle. To me, it makes more sense for me to actually look at it as far as a right angle triangle with SOHCAHTOA. So here's my angle A. Directly across from it is opposite. Directly across from the right angle is hypotenuse. And you can see adjacent, I have nothing about it. So I want a ratio that uses opposite and hypotenuse, which is sine again. So we're going to do sine of a theta. Okay, so that still comes in, equals opposite over hypotenuse. We substitute our information in, and I'm just going to make that thinner because it's easier to write with. So we have sine of 72.5 degrees equals opposite, which is our H that we want to find, over the 312. Now all I need to do is multiply both sides by 312, and I end up with H by itself. And when I do that, I end up with 298. So therefore, the clouds are 298 feet high. Now, measuring something like this, the height of a cloud, is one real good application of trigonometry because we can't take a ladder and measure from the ground up to the clouds. I mean, that we just don't have the ability to do that. So measuring in this way is one aspect that we can do with trigonometry. Okay, and could we actually do that ourselves? We could. Do we really want to? Probably not, especially if it's especially we would have to do clouds, spotlight up. So we'd have to have the right weather for sure and maybe the right time of day. So that's not going to happen for us. Okay, so lots of questions for you to work on tomorrow.